All right, all right. So we just solved two easy linked list questions. Now it's time to kind of move on and see if we can do a medium. So let me make myself a little bit smaller. There we go. And I guess we have to go back to the. Um, actually, let's do this one, linked list cycle, because it's the next one. Let's just do it. Let's do it. Okay, fine. We're not doing a medium yet. We're doing another easy, but that'll be fine. All right. So here we go. Linked list cycle detection. Okay, so first off, before we even start, what is a cycle? A cycle is when we have kind of a loop. All right, so given the beginning of a linked list head, return true if there's a cycle in the linked list, otherwise return false. Okay, so we're trying to determine, is there a cycle or is there not a cycle? There's a cycle in a linked list if at least one node in the list can be visited by the following next pointer. By following the next pointer. Okay, so if at least one node in the list can be visited again. Yep. So what I'm thinking about doing is, okay, so internally index determines the index of the beginning of the cycle. If it exists, the tail node of the linked list is set to next pointer in the indexth node. If index is -1, then the tail node points to null and no cycles exist. Okay, so I guess, do we just need to return a Boolean or do we need to do something in place? I don't actually know what this means. Let me try to reread this to understand. Okay, so internally, index, are we given index? No. Okay. Is there a definition of what index means? So here, index is -1. Well, that's constraints. Or a valid index of the linked list. Do we have to... I'm trying to figure out if index is... All right. Internally, index determines the index of the beginning of the cycle, if it exists. The tail node of the list will set its next pointer to the indexed node. Yeah. If index is -1, then the tail node points to null and no cycle exists. So I'm trying to figure out, so no, index is not given to you as a parameter. Do we need to create something called index? And is part of the question actually to find the beginning? Or is it just to say true or false? So I guess what I'm thinking about doing is creating a stack and then going through. So I'll add 1 to the stack, I'll add 2 to the stack, I'll add 3 to the stack, I'll add 4 to the stack, and then I come and I see that I've hit 2 again, and 2 is already in my stack. So I know 2 is where the cycle begins. So I just set index is equal to 2 and then enjoy my life. Maybe, I don't know. Index is equal to -1. Okay, so I'm going to say current is equal to head. Now while current, okay, so I also need a stack, so I'm going to say my stack is equal to a list, or do I need a set? Okay, so I'm going to say if current in my set That means that we found it. So what do I want to do? I want to say index is equal to, oh, do we have to say the, we have to say the index at which it occurs? I really wish I understood the problem a little bit better. Like, do we actually need to do that, or do we just return true or false? I don't know. So how are we gonna do that? Maybe I say it's a dictionary. So default dict. And so we're going to have a key value, and the key is going to be the number, and the value is going to be the index, both of which are integers, but we care about the value, so this is going to be int. There. Okay, so I'm going to say current index is equal to 0. Okay. We do something. I don't really know what we do right now, but I'm going to say otherwise I want to add this node into my dictionary. So what I can do is say my dictionary indexed at I'm also noticing, are these always in order? Because if the value is the index, my dictionary current is equal to current index, okay, and then at the end of this while loop I want to say current index plus equals 1, okay. So then I can say index, the real index, is equal to my dictionary indexed at this current, right? Because that's the beginning of the loop, and that will give me back the actual, like the index at which it occurs. Okay, so I store that there, and then I say return true. Okay, and then if we do all of this and we, and then we want to say current equals current dot next. Okay, and then I want to, if we exit out of this, we get to null. I can say return return false. Okay. Okay, let's try it. I have no idea. Sure, I guess. Well, it was accepted. I don't know if this is the best solution, so let's go look at the solutions and see, like, what are the different options available to us. Okay, so we can have a hash set. All right. So it looks like they're not really doing the slow and fast pointers. It looks like they don't care about this internal variable called index, which was kind of what was throwing me off. Okay, so this is kind of the way that I was thinking about doing it. I just do a set, and then I say current is equal to head, yeah. So while current, and then if it's seen, return true. Otherwise, add it to the set, and then move to the next one. If we exit out, it's false. Okay, that's kind of what I was doing. All right, so adds fast and slow pointers. I remember that this is a way to find cycles in a graph. And I think the idea comes out to be like if you go 2 ahead, it's something I need to review, but I remember if you do 2 ahead, eventually you get back to the same node. But I can't remember how long you have to do that to be guaranteed to actually hit that second or the same node again. So we have fast and slow, and both of them are initialized to head. So while fast and fast dot next, okay, sure. Oh, that's because we're going to be doing fast and then 2 ahead, okay? So slow is equal to the next one. So we go 1 over, and then fast we go 2 over, okay? And we don't need to care about slow because fast is always going to be ahead of it. Okay, so if fast is equal, or if slow and fast ever match up, and I guess this is going, so if there is a cycle, this is always going to be true. And we are just going to do this maybe 1,000 times until they converge into each other. So we say if they are the same, then return true, otherwise false. So it's saying time complexity is O of n. So is it guaranteed that it's going to do it within at least one iteration through all of them? Interesting. Okay. There we go. All right, cool. So I guess that in the next video we will go and try to conquer that next one, the medium. So let's try to see if we can get it. So yeah, if you want to see that, subscribe, and I will be back soon with another video, and we're going to try this reorder list. Okay, so we'll try this one next. Thank you guys for watching. My name is Timothy Lee Grant. I'll see you guys very soon.